Sources of city water contamination. After we turn on the faucet, we expect our water to be clear and secure. Much of our country's tap water comes from rivers, streams, lakes and groundwater. Many water companies spend a great deal of time and money on treatment or purification processes because our water sources can be so polluted that basic water treatment does not remove all contaminants. For water suppliers, protecting water sources and watersheds from pollution is smart economically. Preventing contaminants from entering the water is more cost-effective than having to remove them year after year. However, the resources available for drinking water and the protection of water sources are very insufficient. Where does the pollution come from? Here are some of the main sources of water contamination. 1. Agriculture. Agricultural activities are one of the major sources of water pollution in rivers, streams, lakes, and groundwater in the United States. Every year, farmers apply more than 12 million tons of nitrogen fertilizer and 8 million tons of phosphorus fertilizer to cropland, some of which flows into water sources. Manure is another important source of water contamination. It is estimated that livestock produce up to 1 billion tons of manure each year, and runoff from farms and feedlots can be laden with sediment and pathogenic microorganisms. In addition, many pesticides are not subject to federal drinking water limits, which means that utilities and their customers have no reference point to know whether the amount of a specific pesticide in the water is safe. Many water firms in agricultural countries are obliged to treat water supplies to remove pollutants related to agriculture, often relying on expensive processes such as carbon treatment and ion exchange. Despite the efforts of these companies, agricultural contaminants are detected in the drinking water distributed to millions of Americans each year. 2. Industry. The Environmental Protection Agency's EPA Toxic Release Inventory Notification Program shows that in 2015, U.S. industries and businesses released 191 million pounds of chemicals into rivers and streams, some of which are used as sources of drinking water. Many of these chemicals can be legally present in our drinking water at any concentration because federal or state authorities have not set enforceable limits. 3. Urban areas and suburban sprawl. Sewage and runoff are mixed with pollutants from urban areas and suburban sprawl, chemicals from vehicle emissions, road surfaces, yards and homes. Scientists are also finding that rivers, streams and, in consequence, consuming water are contaminated with traces of pharmaceuticals, antimicrobial chemical substances comparable to family pesticides, flame retardants, gasoline components and different chemical substances that scientists have linked to dangerous health effects. Pharmaceuticals and personal care chemicals are excreted in human urine or discharged to sewers. Many are not removed by standard treatment processes at wastewater treatment plants. Because the U.S. inhabitants continues to develop and extra land is cleared for housing and agriculture, the variety of contaminants polluting lakes and rivers is rising, based on a 2012 U.S. Geological Survey research. This, in turn, might result in elevated air pollution of faucet water. Without a coordinated, national initiative to control pollution from sprawl, municipal water users should continue to expect to find many of these pollutants in their drinking water. 4. Water treatment, storage and distribution. Disinfection of drinking water is essential and saves lives from microbial diseases. But when chlorine and other disinfectants react with plant and animal waste in the water, harmful disinfection byproducts are formed. Agricultural and urban runoff is the primary supply of natural matter, and subsequently the primary explanation for extreme ranges of disinfection byproducts in faucet water. Scientists have identified greater than 600 disinfection byproducts in treated drinking water, a number of the most common of which have been linked to DNA harm and cancer. Water tanks and distribution system pipes, including domestic pipes, also add contaminants to drinking water, such as lead, copper and chemicals that can escape from plastic pipes. Lead from lead-based pipes and solder can leach into water, and storage tanks and pipes lined with asphalt or coal tar chemicals have been linked to cancer. The EPA estimates that more than $600 billion is needed to improve water infrastructure over the next 20 years. While much of this money is needed for basic reconstruction of our country's deteriorating water system, it will also go a long way toward reducing the leaching of contaminants from aging pipes into drinking water. 5. Natural contamination. Not all water contamination is caused by human activity. Some of it occurs naturally, but the amount of water can be increased due to the conversion of forest land to mining, agriculture and housing developments. Radioactive chemicals, metals and other elements are natural components of soil and rocks that can dissolve in rivers, streams and groundwater sources. Radioactive substances and metals such as arsenic and lead are known to be harmful to health, and all measures must be taken to limit their presence. 6. Contamination through urban water supply. Most municipal water treatment plants filter the water to remove particles, then apply disinfectants and chemicals to remove harmful microbes and other contaminants from the water. Unless equipment malfunction, flooding or human error occurs, the water that comes from your city's water supply should be safe to drink. However, to produce clean water, certain chemicals must be added to the water and some consumers prefer to remove them before consuming the water. The most common additives in our drinking water are chlorine, chloramines and fluoride. Small amounts of chlorine are commonly added to drinking water supplies to kill harmful bacteria, viruses and other microbes. Although chlorine can be safely consumed in these amounts, many people do not like the taste and smell. Showering in chlorinated water can also cause dry, itchy skin. For these reasons, some people use inexpensive activated carbon filters in water jugs or attached to taps to remove chlorine from the water. Chloramines are another substance used to disinfect water, although they are much less effective than chlorine. They are formed when chlorine comes into contact with ammonia. Many municipal water systems treat water with chloramines or treat water first with chlorine and then add ammonia. As with chlorine, it is easy to use chloramines with carbon filtration. 7. Piping system contamination. The two most common contaminants in our consuming water are copper and lead. Rather than coming from our municipal water provide, these minerals leach into our consuming water from the pipes used to carry water in our properties. Lead poisoning can occur gradually and often without warning. Although lead has a somewhat metallic and sweet taste, it can be difficult to recognize in drinking water. It enters our water through corrosion of old pipes, lead solder and brass fittings. Symptoms of lead poisoning include vomiting, constipation, stomach pain and irritability. Copper is another contaminant that can enter our water supply through corrosion. Although humans need traces of copper in their diet, too much copper can be toxic. As with lead, copper poisoning can cause nausea and stomach pain, vomiting and other flu-like symptoms, and long-term exposure can lead to liver poisoning, kidney failure and anemia. Number 8. Well water contaminants. People who get their water from wells do not necessarily have to deal with chemicals from other sources, but they must be equally concerned about the quality of their water. Well water can contain high levels of dissolved minerals and chemicals leached from surrounding soils, agricultural runoff and natural but dangerous microbes. Arsenic, a toxin that can escape from natural deposits or enter groundwater from sources as varied as mining, oil and gas extraction, pesticide use and treated wood, is one of the greatest hazards to well water. Fertilizers and pesticides, as well as nitrates and nitrites from fertilizers, animal waste and septic tanks, are another common contaminant to well water. Finally, well water must also be disinfected to prevent the consumption of various microbes, including fecal coliforms and E. coli, two bacteria that can enter groundwater from agricultural runoff. Water contaminants and their treatment. Many traditional sources of freshwater, both surface water and groundwater, may contain visible and invisible contaminants that make them unfit for consumption. Several parameters are used to classify contaminant: inorganic, organic, radiological, microbiological and aesthetic. 1. Inorganic contaminants. Inorganic contaminants include minerals such as metals, heavy metals and metalloids, as well as nitrogen-oxygen chemicals such as nitrites and nitrates. Arsenic is a metalloid of high concern. Hazards include skin damage, circulatory problems and an increased risk of cancer. Arsenic removal technologies include coagulation and oxidative filtration, adsorption, ion exchange and membrane filtration. Nitrates, another contaminant due to their use in fertilizers and their presence in human and animal wastes, are often introduced into water supplies through sewage and runoff from farmland and livestock. A very effective disposal technology is the new membrane aerated biofilm reactor, MABR. 2. Organic contaminants. An organic compound of great concern because of its widespread use as an industrial solvent and its health hazards is benzene, which is linked to anemia, reduced blood platelets and cancer. The most effective technology for removing benzene is air stripping. Radiological contaminants. One of the most dangerous radiological threats to drinking water is radon gas, which emits alpha radiation. The EPA considers no level of exposure to radon gas to be safe, and it is the second leading cause of lung cancer after smoking. In some cases, radon has been found to enter and accumulate in homes through well water. Radon-contaminated water can be treated by carbon filtration, but since carbonaceous media can become dangerously radioactive after absorbing sufficient gas, the most effective treatment method is air stripping. Microbial contaminants. One of the microbial contaminants of greatest concern is fecal coliform bacteria. It is not in itself a health threat, but its presence may indicate the presence of other disease-causing microbes. It is widespread throughout the world and enters the environment through fecal matter from untreated or inadequately treated sewage, livestock runoff and leaking septic systems. Turbidity, or lack of clarity, can also be an indicator of microbial contamination. Pathogens that may be present with coliform bacteria and turbidity include Legionella, parasites and viruses. Many pathogens in water cause diarrhea, a major cause of death in the developing world. Typhoid, cholera and dysentery were common before the start of water system disinfection. Stop contamination. What can you do to keep your water safe? First, if your water is colored, usually rusty or yellow, or has an unusual odor or taste, stop using it immediately. Especially after heavy rains, but also at other times, water treatment plants can have temporary water treatment problems. Check with a city information phone line or the local media to find out if a boil water advisory or any other water advisories have been issued. You can test your water with portable kits or a certified lab. Next, consider installing a water treatment system in your home, and be sure to bring water filtration and disinfection systems with you on camping and hiking trips. If you wish to treat your water at home, you have two options: entry point systems. These are water treatment options that are installed at the water meter or storage tank and treat all the water entering your home. They can be relatively expensive to install and maintain, but care must be taken to ensure that minerals and other contaminants are removed from water used for cooking and bathing and in appliances such as washing machines, water heaters and ice makers. Point-of-use systems. They are much less expensive than point-of-entry systems and include filtration units on kitchen taps, shower heads or in refrigerators. You can also purchase water jugs or countertop filtration units. Most of them have activated carbon filters that need to be replaced regularly. You can even install a reverse osmosis unit below the sink that may filter your water for cooking and consuming.